You're watching TelecomTV's exclusive coverage of Broadband World Forum 2015 from London. I'm joined now by Brian Ahern of Intel and Håkan Djuphammar of Ericsson. Gentlemen, thank you both for joining me today. Brian, if I can start and address the issue of NFV. There's been a lot of talk for several years about NFV and the standard's been developed over the past 2-3 years within ETSI. It's moving out of trials now, moving through proofs of concept. Where is the move to commercial NFV happening first?
Yes, so you're absolutely right. The last couple of years have been characterized by proof of concept after proof of concept at trade shows for the, and it's been a journey that's got us now to the point where we're right at the precipice. From what we're seeing a number of operators really on the precipice of that deployment model. There are some really interesting initial use cases such as virtual CPE, but also some of the more traditional ones like IMS and EPC. These are all now right there with all of the major vendors having solutions and product offerings in this space.
Håkan, if I could ask you, where do you think we're going to first see major applications of NFV? Where will applications be virtualized first?
It starts with the more server type of applications, like we see IMS as a control system and also the mobility parts of packet core. But it's already going into payload type of applications, like the payload parts of packet core, and also seeing media resource management codecs and things like that going also into virtualized space. And the last thing we will see is of course the hardcore forwarding applications, which will be later into virtualization. But we have already networks up and running for VoLTE, for instance, based on IMS, fully virtualized today.
Brian, what's needed in order to deploy NFV at scale?
Well, open source is a phenomenal and really important aspect to that. And what I mean by that is we've been collaborating with Ericsson in this space, and one of the areas is enhanced platform awareness, for example, and OpenStack. It's really important that we have the underlying network infrastructure that's capable of meeting the high performance demands of these telecom virtual network functions. So we've been working on OpenStack and Open Daylight and a whole range of open source projects to get that infrastructure ready for that deployment.
Håkan, just how important is open standards and the open source community to the development of NFV?
Well, it's sort of a new paradigm, because if you go back in the world of telecom, we've done standards first, agreed on the protocols, and then we build it. But this world is slightly different. You code and you contribute code, and the best code wins, and that becomes the standard. It's more a de facto type of standardization. What is a bit lacking is the complete system thinking, though, because we have open source activities, as you said, on ODL, OpenStack, blah blah blah. We have to pitch that together and make something work as a complete deliverable. And that's why we're using OPNFV as the body to actually bring those contributions into one distribution and make sure that that is troubleshooted into the lowest level, that you get the performance, which we do through a yardstick activity, which we call it, where we actually benchmark different types of application on top of the OPNFV execution. So we have to industrialize this as well. So take the open source momentum and put some law and order around it and make sure that we get a homogeneous industry standard, basically.
Brian, Intel's a big supporter as well of open standards in NFV. Quite a challenge to make this shift in thinking and to get telcos thinking that way?
Yes, we're platinum members of OPNFV, and this is incredibly important aspect to, as Håkan said, to industrialize and pull together all of those components and deliver that underlying infrastructure that's capable of meeting those high performance demands. Intel has also got an open networking platform. That's a reference platform that provides customers with a fast start to NFV development and deployment.
Can I move over to IoT? And Håkan, we've seen Ericsson here at the show talk about IoT. What are the demands that IoT is going to place on infrastructure?
Well, it's hitting the infrastructure in several different areas. One is that the radio access actually needs to be adapted to suit this type of use case better. So we have LTE narrowband being standardized as we speak, which gives 20 dB better coverage, so you can reach better into buildings and far out in the rural areas. Longer duty cycle, which means lower energy consumption in the devices. You can do smaller devices, cheaper devices, longer battery lifetime. So that gives the possibility to actually explode the number of devices and use cases based on the new radio access. Then all the provisioning systems needs to change. Because when you provision a subscriber today, a smartphone subscriber, you have to configure a lot of things like voicemail or not, what's your home address, where you send invoices every month or every second month, blah, blah, blah. That's not applicable for a power meter. You provision 1 million power meters with a click. That's how you need to do it. So we're providing solutions where you actually do all that provisioning outside of the operator in the cloud and do a very efficient management of large-scale deployment of devices. And security solutions on top of that, and portals so that the enterprises can manage their devices without having to go through an operator. And it actually also provides a multi-operator connectivity, so you can get global connectivity on your device if that happens to be a car or something like that that can show up anywhere in the world, and you can just lift up the application in the cloud and then manage the connectivity from a platform perspective. So that's basically the elements. Better radio access, much easier provisioning systems, but then an execution environment and an application development environment which makes it possible to efficiently develop applications to run those devices.
Brian, how is Intel helping in this transition and supporting operators as they transition their infrastructure?
Well, this is music to our ears. We have this remote sensing capability, smart aggregation of that data, secure capture of that data. Then you have the hyperscale cloud infrastructure, and then this secure communications infrastructure in between. And we have a product portfolio that goes from our IoT portfolio all the way through the network infrastructure to the hyperscale cloud infrastructure. Yes.
And Håkan, when we look at IoT, the demands on the network, how does it impact cloud usage specifically?
It's I would say that it will be such a scale on those deployments. We talk about billions of devices that needs to have an application that manages those. It has to be centralized and scale very rapidly. It's like the new web applications that goes from 10 users to 10 million users in 2 weeks. We will see the same thing happening on the machine and IoT space. You will be flooded with new devices that need to be managed, and you have to have the same capability to quickly scale and manage the innovation that happens in the space. So we need the clouds to actually cater for that.
Now, Brian, the very fact that the two of you are here together during the same interview, you are partnering together, Intel and Ericsson. Tell me a little bit more about what the two of you are doing together.
Sure. We have a rich history of partnership in data networking, and there are really 3 pillars to what we've been doing. We've been working together on performance optimization of the data plane, using Intel Data Plane DK or Data Plane Development Kit technology. We've been working together on open source through with enhanced platform awareness, as I've already mentioned. And finally, we've been working together around cloud and data center technologies, specifically our Intel rack scale architecture. So our partnership and collaboration spans all of those. It includes engineer-to-engineer relationships and joint go-to-market activities.
And Håkan, what's the value of the partnership to Ericsson?
It's several aspects, as Brian said. We cooperate in standards, of course, or open source activities to drive the same agenda and to move the industry forward. But as an example, we use the Intel rack scale architecture to build our HTS 8000 product, which is a hyperscale data center product with disaggregated hardware and optical backplanes, basically software defined hardware. And that wouldn't be possible without the cooperation with Intel that provides the rack scale architecture as a foundation. Another example is in the IoT space. We yesterday just launched this IoT system to manage vineyards. You measure humidity, temperature, hours with sunshine and these things in order to optimize the production or do the harvest of the grapes at the most optimum time. That is a capillary network which actually uses Wi-Fi or Zigbee to a gateway, which then connects through the cellular system to a back office operation center in the cloud. In that gateway, we're using Intel's platform, and we're using that to be able to build a secure encrypted end-to-end connectivity out to all these devices to make it tamper-free. So we cooperate in many different areas here and complement each other in those spaces in many touch points.
Håkan, Brian, thank you very much indeed.
Thank you.
Thank you.